Hi! Today, we're going to talk about one of the most fascinating and mysterious technologies in the world, quantum computing. What is it? How does it work? Will it help us or cause problems? Stay with us because we'll explain it clearly and simply. But what exactly is quantum computing? Let's start with the basics. First, what's the difference between a classical computer, like the one you have at home, and a quantum one? Classical computers, the ones we use every day, like laptops, phones, and even big cloud computers, work with something called bits. A bit is a unit of information that can be either 0 or 1. It's like a light switch. It's either off or on. No in-betweens. It's a pretty simple system, but limited in its ability to do complex calculations. Now, in the quantum world, here come the qubits. And this is where things get interesting. Imagine that instead of a simple switch, you have a coin spinning in the air. While it spins, it's in two states at the same time, heads and tails. 0 and 1. That's a qubit. It can be in several states at once, thanks to a quantum phenomenon called superposition. This simple yet powerful concept allows quantum computers to perform calculations at speeds we can't even imagine with classical machines. It's like they can perform thousands of operations simultaneously. Incredible, right? But that's not all. There's something even more surprising. Unlike digital bits, which are just values of information, qubits are physical. What does that mean? It means qubits aren't just numbers. They're made of subatomic particles, like atoms or electrons. And because of that physical nature, they can exist in multiple states at once, not just 0 or 1, but combining those values. This gives them far greater power than digital bits. So, while bits in traditional computers can only be 0 or 1, qubits in quantum computers can do so much more. Let's talk about the quantum principles of superposition and entanglement, two concepts that make quantum computing so powerful. Now that we know qubits can exist in multiple states at once, let's see how superposition works. This phenomenon is like if your coin spinning in the air wasn't just heads or tails, but a mix of both at the same time. Imagine that, instead of being one or the other, a qubit can be both 0 and 1 simultaneously. This allows quantum computers to perform calculations much faster and in ways that classical computers cannot. That's not all. There's another quantum principle that takes things even further: quantum entanglement. It sounds strange, but imagine you have two magic dice. When you roll one, the other instantly shows the same number, no matter how far apart they are. This is how entangled qubits work. They are connected in a special way, and the state of one instantly affects the state of the other, regardless of how far apart they are. And the most fascinating part is that this entanglement remains even if the qubits are separated by thousands of kilometers. It's as if they were teleported in the blink of an eye. Now, why is quantum computing much faster than classical computing? Let's dive into that. In traditional computers, everything is based on bits, which can only have one of two values, 0 or 1. When there's a problem with multiple possible solutions, the classical computer has to try each one separately. This means that, for example, if you're solving a problem with 100 possible results, the traditional computer would have to make 100 sequential calculations to test each one. It's like being in a race where you can only try one route at a time. You'd have to go all the way, return to the starting point, and then try another route. This process becomes slow when the number of possible paths grows a lot, like in complex optimization or simulation problems. Now, in quantum computing, things change completely. Thanks to qubit superposition, instead of testing one path after another, qubits can be in multiple states at once. This means that if there are 100 possible results, the quantum computer can explore all those paths simultaneously, as if you were traveling down all 100 routes at the same time, without having to go back to the starting point every time. This quantum parallelization power is one of the reasons quantum computing is much faster. Qubits aren't working on a single path at a time. Instead, they perform calculations in parallel, testing all possible solutions at once. And only when you need a result, the state of the qubits is measured, and they collapse into a single value. Also, when qubits are entangled, even if they're separated by very large distances, their states are strongly connected. This means that a change in one qubit can instantly affect another, allowing for a very efficient exchange of information. This is something that can't happen in classical computers where bits are independent and don't have that instantaneous interconnection. What is quantum computing for? Now that we understand a bit about how qubits work and the principles of quantum mechanics, let's take a look at what quantum computing is really used for. Because yes, this is not just science fiction. This technology is already starting to have a real impact. For example, in medicine, researchers are using quantum computers to simulate molecules. Imagine being able to model the behavior of a molecule so precisely that we could develop new drugs for diseases like cancer, and much faster than with traditional methods. In the field of security, quantum computing is taking cryptography to the next level. With quantum cryptography, we can create security systems so advanced that they would be virtually impossible to hack. It's like having a lock that can never be opened, not even by the most powerful computers of the future. And in the world of artificial intelligence, quantum computing could be the key to improving data optimization. We could make faster and more accurate decisions in areas like weather prediction, improving machine learning algorithms, or even coming up with new solutions for climate change. Big companies like Google and IBM are already making giant strides in harnessing quantum computing, and the best is yet to come. Can you imagine everything we could achieve with such powerful machines? Why don't we use quantum computers yet? Now that we know how amazing quantum computing can be, you might be wondering, if it's so great, why don't we have quantum computers at home? Well, the reality is that although we're on the right track, there are some big obstacles we still need to overcome. First, quantum computers need to be at temperatures close to absolute zero, meaning colder than outer space. This is because qubits are so fragile that if they get too warm, they lose their quantum properties and stop working. Additionally, they are extremely unstable. A qubit can be influenced by almost anything, like environmental noise, which causes errors. Imagine you're doing a super important calculation, but suddenly everything goes wrong because of a small error. That's a big challenge. And lastly, the cost. Creating and maintaining a quantum computer is so expensive that only a few research labs and big corporations like Google, IBM, and Microsoft can afford it. It's like we're in the early days of classical computing, when computers were only in the hands of governments or big companies. So, when will we see quantum computers in real life? The good news is that the technology is advancing rapidly. Although there's still a long way to go, quantum computers are improving more and more, and researchers are working tirelessly to overcome the current obstacles. Some experts believe that in the next 10 to 20 years, we could start seeing quantum computers that can be used by businesses, researchers, and even governments to solve complex problems. Imagine everything we could achieve with these machines, from cures for diseases to breakthroughs in science that today we can't even imagine. But could they replace classical computers? Not necessarily. Quantum computing isn't designed to do everything our current computers do, but it does have the potential to do things that traditional computers could never do, like simulating complex molecules, creating unbreakable cryptography, and much more. And of course, the impact on cybersecurity will be tremendous. Quantum computers could break many of the current security systems, but they could also open new doors to create much more robust protection systems. Artificial intelligence would also benefit, speeding up decision-making and optimizing data processing like never before. We are in the age of quantum computing, but the question remains, are we ready for what it will bring. With every breakthrough, this technology opens new doors for us, but it also presents huge challenges. Quantum computing could be the future, an incredible advancement that will change everything we know about the power of machines. But it could also bring new risks. Will it be a tool we use to improve our lives, or something we need to handle very carefully? And now, I leave you with a question. Do you think quantum computing will be humanity's greatest advancement, or a step into the unknown? Leave me your opinion in the comments. Thanks for joining me on this amazing journey into the world of quantum computing. See you in the next video.